So friends, today we are going to solve Dpp-1 of maths, JEE advanced questions. Here is a look of questions. These questions we are going to solve in our today's session. So have a careful look each time when we are solving these questions one by one. Let's begin with the first question. So you can see the question on our previous slide. Now we have given it is given in this question that a plus b plus c equals to 0 and a square plus b square plus c square is equals to 1. Now we have to calculate a raised to the power 4 plus b raised to the power 4 plus c raised to the power 4. Let us begin with our first equation, a plus b plus c equals to 0. On squaring both sides, we get a plus b plus c whole square equals to 0. On further expanding this term, we get a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Now, we have given the value of a square plus b square plus c square equals to 1. We substitute this value in this equation. Then we get 1 plus 2 bracket ab plus bc plus ca equals to 0. After solving this, we get the value of ab plus bc plus ca equals to minus half. On squaring both sides, we get ab plus bc plus ca whole square equals to 4. Then, which further on expanding gives us the equation number b, as you can see on the screen. We get equation b. In equation b, we have value of a plus b plus c equals to 0, which makes this term completely 0. Then we get the value of a square b square plus b square c square plus c square a square equals to 1 by 4. Now we have to calculate a raised to the power 4 plus b raised to the power 4 plus c raised to the power 4, which comes in the expansion of a square plus b square plus c square complete power whole square. Then on expanding this equation further, we get a raised to the power 4 plus b raised to the power 4 plus c raised to the power 4 plus 2 times the rest which we have left over in the equation b, and which is again equals to 1 by 4. Now by solving this equation further, we get the required value of a raised to the power 4 plus b raised to the power 4 plus c raised to the power 4 equals to 1 upon 2. Hence 1 upon 2 is the required answer. Now we will solve our next question. Let's have a look on our next question. Here it is. You can take a screenshot of this slide for your help. Well, here it is. We have to prove in this equation that LHS side of this equation is equals to RHS side of this equation. Now by taking RHS side, we open up this a plus b plus c whole square, because there are three terms given in this equation, which equals to 1 upon x minus y whole square plus 1 upon y minus z whole square plus 1 upon z minus x whole square plus 2 times. Now this equation, this particular term in front of 2 is written by taking LCMs, so it is very easily done. You can also do it by yourself, and by cancelling each term we get 0. So this complete term equals to 0. Well, then we get a required answer, and hence it is proved. Well, I know that this is quite an easy one question. There are less chances of this question to come in JEE Advanced, but it can come in any another way in JEE Mains. So we have to do every question with very importance, and we have to give very importance to every question. There more and more practice will open up our mind for new questions. Now let us again have a look on our third question. You can take a screenshot for your convenience. Now we will be solving third question. Well, this was the given equation in our question number 3. So this is quite simple. This is based on our concept of componendo and dividendo. I have explained componendo and dividendo in a side corner of this slide. You can see. So in this question we have used componendo and dividendo. It's quite an easy concept. You can see I have solved it on the screen, and then I have take common from the terms, and then I have cross multiplied them. It's quite easy. We get x equals to ab by c. This is our required answer. So friends, don't forget your old concepts. These are also equally important. IIT can ask any basic concept related question. Now let us have a look on our questions. Now we are going to solve the fourth question in our next slide. So here it is. In this question we have given that p, q and r are positive integers and p, q and r are prime numbers, and a condition is given that p square minus q square is equals to r. We have to find possible value of r. So friends, I am constantly explaining you that you have to write the given conditions, you have to identify the given conditions, and we have to find that what question wants us to solve, exactly what is the real question. Let's for example, we say that in this question we have to find possible value of r. That would be the answer of our questions. Let us begin. Here we have given the condition p square minus q square equals to r. After factorizing this, we get p minus q into p plus q. When equating these two with r into 1, we get p minus q equals to 1 and p plus q equals to r. Now you can cross question me that why p minus q is not equals to r and why p plus q is not equals to 1. And well, I have written in the brackets that addition of two positive prime numbers can't be 1. So there is only one possibility left, that p minus q should be equals to 1 only. I have also explained about the prime numbers, that prime numbers have only two factors, that is 1 and the number itself. It means only the number itself and the 1 can divide a prime number completely, right? So by hit and trial we get p equals to 3, q equals to 2 and r equals to 5, but our answer is only r equals to 5. It is an integer type question. Now we know that it is an integer type question, so its answer is r equals to 5. Now let us look on our fifth question. Here is the fifth question. We have to find the solution set of the equation 2x plus 3 mod minus x minus 1 mod equals to 6, and here we get the solution. Well, we have to solve this question by making cases, because in mod questions we make cases. In the case first, when x is greater than or equals to 1, we get 2x plus 3, and the mod of x minus 1 opens up with positive signs, which gives us minus x minus 1 equals to 6. Here we get x equals to 2 as the only value of x, which is the equation number 1. Now in case 2, when x is less than 1 but greater than and equals to minus 3 by 2, the bracket of x minus 1 opens up with a negative sign, which further gives us 3x equals to 4, and we get the value of x equals to 4 by 3. But since x is less than 1 and greater than minus 3 by 2 and equals to, therefore x belongs to 5. It means null set. There is no solution of this equation. Now we will take case third. In case third, we have x less than minus 3 by 2. When we open up, here we will open up the bracket of 2x plus 3 with a negative sign, and also the bracket of x minus 1 with the negative sign. Then we get the value of x equals to minus 10. Therefore the solution set is only minus 10 and 2. so it is written in the set form. Now I think I have forgotten question number 5 to solve, so let us have a look on question number 5th, which we are going to solve next. I'm sorry for that mistake. Here it's the solution of the question number 5th. So we have assumed z equals to the given equations. Well, z equals to x minus p mod plus x minus 15 mod plus x minus 15 minus p mod. Also in this question we have given the condition that x is less than 15 and greater than p, and p is less than 15 and greater than 0. Now by opening mode of this equation one by one, since x is greater than p, so x minus p will be open up with positive sign. Since x is less than 15, so it will be open up with the negative sign. And the third mode, since x is less than 15, so this goes for negative and we have to make it positive, so we open up with a negative sign. On opening these brackets we get 30 minus x, and we now have to show that z has to be minimum, and for z to be minimum we have to find maximum value of x, but maximum value of x can be 15 because x, the range of x is only from p to 15, and 15 is the highest value that x can take. Therefore we have to put 15 in x, then z minimum we get 30 minus 15, which is equals to 15. Therefore 15 is our required answer. Next, so let's have a look on our 7th question. We have to calculate the least value of x satisfying the above equation. Now let us do it. So you can have a look on the given equation. I have noted down. Now the case 1 arises when x equals and greater than 0. So here we get 2 raised to the power x plus 1 minus 2 power x equals to 2 raised to the power x minus 1 plus 1 cancel out here, and in further solving we get the equation is satisfied, but we get x equals to 1 as the solution in this equation. So now here it is the case 2. In case 2, x is less than 0 and greater than equals to minus 1. In this equation, we on the right hand side, the expression 2 raised to the power x minus 1 opens up with a negative sign because x is less than 0 but greater than minus 1. And on the left hand side, the expression 2 raised to the power mod x plus 1 opens up with a positive sign. On solving this, we get 2 raised to the power x plus 1. So we get 2 raised to the power x plus 1 equals to 2, which gives us x equals to 0. And x equals to 0 is not possible in this case because x we have taken initially in the case 2 that x is less than 0. There is no equals to sign there, so it can't be equals to 0. Now look at, now we have case 3rd when x is less than minus 1. Here we get, this is the required equation. This you can easily get when we solve it with our rules. Now from these equations we get x equals to minus 2. Hence x equals to minus 2 is the least value of x, and this is the solution of question number 7th. Now here we have get the solution of question number 8. From case 1 of previous question, that is the question number 7, we can see that x holds for all values greater than 0, that is x is greater than equals to 0. Hence number of integers less than 15 are 16 integers. 16 of them I have written all of them here. So This is the answer of question number 8. And now the last question of our today's session, question number 9. And here also the solution of question number 9 is given, that composite numbers less than 20 and co-prime with 4 equals to two integers only, that is 9 and 15. Well, I must know that you know the meaning of co-prime numbers, or we will discuss it later in other videos. Thank you all. Now I request you all to please share and subscribe this channel for more videos, and encourage us by liking our videos and sharing more and more to your friends and family members and other relatives, and with your coaching institutes also.